In the last video, I talked about probit regression. And I also mentioned that generalized linear models may be considered as a black box where the response is allowed to be a discrete random variable. I shall first cast the probit regression setup in that black box format. So there we have this black box, the mouse, and we are feeding in dose, and what we are getting is death. Now death or no death. So that is a binary output, a 1-0 thing. And we of course have some amount of randomness going in, but now the randomness is really not additive. But the same idea is there. Death is a random quantity, a random variable, discrete, which is partly explained by what dose you have applied and partly by the inherent randomness of the system. Now when we modeled it in the following way. We said that we are going to take death, and that follows a Bernoulli distribution, not a normal distribution anymore, but a Bernoulli distribution with a parameter p, which was given by capital phi, normal CDF, of something which is linear in the input dose. So that was the way we had modeled it, and this is an example of a generalized linear model. I am linking up the distribution of the response with something which is linear in the input, but the distribution need not be Gaussian, and there is this nonlinear function capital phi sitting here. Now there is nothing which says that you have to use capital phi. You could have used some other CDF f if we believe that the random variable lethal dose follows some other distribution. So you could as well use some other capital F distribution function. Now there are various choices that we can put there. Possibly the most popular choice, which is used outside bioassay, is the so-called logistic distribution, and the logistic distribution function is this: fx equal to e to the power x divided by 1 plus e to the power x. So if I put that, then the resulting thing will not be a probit regression model, but a logistic regression model. And that model is one of the most popular models all over statistics. So it is used for things like credit risking in banks, where the output is whether a particular loan is a good loan or a bad loan, and the input is an input consists of lots of different known informations about the person to whom the loan has been granted. Now let us see what is the general form of a generalized linear model. Now we start just like in a linear model. We start with these two important things, namely your response and the part which we use to explain that response. So you have y and x, the design matrix. Now you have to link them up. Now the way we link them up in a linear model was by saying expected value of y is equal to x beta, together with some other assumptions like whether it is homoscedastic, heteroscedastic, or what is the distribution. But the main thing that connected y with x was this thing. Now when we are working with discrete thing, then possibly the levels of y are basically encoded numbers like 0, 1 or things like that. In that case, we need some other way of linking, but we will use essentially the same thing, but we will take some function of expected y equal to x beta, and that some function is called the link function. In case of probit regression, that sum function was capital phi inverse, because expected y was capital phi of something linear in dose. So if you take it on this side, the link function will be phi inverse. Now there are different possible choices of the link functions. For example, I have already mentioned that if I take phi inverse, then that is called probit. If I take the inverse of the logistic function, then that is called logit, that is f inverse, and you can very easily invert that function. It will turn out to be something like log of x divided by 1 minus x. So that is the logit function. And you can have lots of other such functions as your link function. Now, the link itself is not enough because it merely specifies the behavior of expected value of y. You also need to have some distributional assumption. So you need to specify the distribution. So there are quite a few distributions that are allowed. Here is the list. You can use the binomial distribution or Bernoulli distribution. For example, both probit and logit, they use the Bernoulli distribution. You might use the Poisson distribution. You might even use continuous distributions like gamma, and in fact you can even use the normal distribution. If you do that, then your GLM simply reduces to our standard LM. So LM is a special member of GLM. So these are the different choices, and there may be more, and certain things will go with certain things. For example, if you are working with Poisson, you will typically not use these links, because then you will have to use some other link. So you can do mix and match. So in order to carry out any such GLM fitting, you have to specify the y, the x, a distribution, and a link. So if you specify all these things, then the complete GLM is specified. And in the next video, we shall learn how to specify all these components in order to fit a generalized linear model using R.